Sorry. Hey y'all, welcome back to another Franks and Frasers, where we solve math problems and you tell us which method you prefer.
Is it the Franks method
or the Frasers method? And today, because I know Franks got me last week, I'm sure they're gonna like my method best this week. What are we doing today, Franks?
We are going to find the length of a line segment on a coordinate plane.
I'm a win.
Find the distance of line segment AB. Well, I noticed that the line segment AB is a diagonal. So if I want to find the length of it, I'm going to make a right triangle, and I'm going to treat AB as my hypotenuse. So in order to make a right triangle, I need my ruler. I used my ruler to find a height, which means I drew a vertical line, and then I use my ruler to draw a horizontal line because I can definitely count how long the height is and how long the base is. So my height is 5, 1, 2, 3, 4, 5. And when I count my base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is 12. So now I have created a right triangle, and I'm going to use Pythagorean theorem. A squared plus B squared equals C squared. I'm finding my hypotenuse, so I know my legs. 5 squared plus 12 squared equals C squared. 25 plus 144 equals C squared. 25 plus 144 is 169, which is equal to C squared. And if I'm going to solve for C, I'm going to take the square root of both sides. The square root of 169 is 13, and the square root of C squared is C. So the distance of line segment AB is 13. Let's see how Fraser finds the distance of the line segment.
Hey y'all, Fraser here. So this is how I find the distance of a line segment or a line. I simply need to figure out the coordinates, and then I use my distance formula. So the coordinates for A is -6, right? -6, and I go up 2, -6, 2. And then my coordinate for point B is I go over 6 and 1, 2, 3, down 3. So that is 6, -3. And then I plug it into the distance formula, where the distance formula says D, or distance, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And then I just need to label my points, right? So I'm going to call this my x1, y1, and this is my x2, y2. And then I'm going to substitute these values into the distance formula. So D is equal to the square root of my x2 in this case is 6 minus x1 is -6 squared plus y2 is -3. Y1 is 2 minus 2 squared. So now we just need to simplify. So sorry if you can't see it. So how do you simplify that? 6 minus a -6. Oh, forgot a parenthesis. 6 minus a -6 is really 6 plus 6, which is 12. So this is really 12 squared. Plus -3 minus 2 is really -5. Make sure you keep those parentheses there. And that's squared. So distance is equal to the square root of 144 plus square root of 5 times square root of 5 is 25. Now, what is 144 plus 25? That looks like 169. And I know the square root of 169 is 13, so my distance is equal to plus or minus 13. But remember, this is distance. Distance can't be negative. So although you know that the square root of 169 is plus or minus 13, you can have a negative distance. So your actual answer in context is really just 13. That's how I find the distance of a line. Here's something Franks and Fraser can agree on. The Dope Math Notebook, rulers, and pencils are the best tools to work through any math problem, either in the classroom or at home. The crisp design and endless resources in the Dope Math Notebook will keep you passionate and intrigued about math. Purchase your own Dope Math bundle today or get a sneak peek inside by downloading the reference sheet at dopemath.com.